So for this video, we'll be showing more examples on how to simplify fractions and get its lowest terms. So first, as a recall, in the previous video, we have shown what we mean by simplifying fractions. So say if we have this whole and we divided it into 4 parts, then we shaded 2 of its regions, then this would mean in fractions as 2/4. But since we can treat this one as just divided by 2, since these 2 parts are equal, then this is equal to 1. So that is how to get the lowest terms. So for our first example, let's try to get the lowest terms of 2/12. Now first, just a disclaimer, one of the ways to get this one of the ways to get the lowest terms of a fraction is to get their GCF. But I wouldn't do that in this example as well as the following example, since I prefer trimming the numbers down step by step. I'll talk about that more later. So for this example, observe that both the numbers in the numerator and denominator are divisible by 2. So we can factor out 2 out here like this, canceling 2, and this would give us 1/6. So that is its lowest terms. Let's go on to our next example. Say if we have 6/8. Again, both of these numbers are divisible by 2. So we can factor 2 out. That will give us 2 times 3 and 2 times 4. So we can cancel this one out, and that would give us 3/4. Observe that 3 and 4 doesn't have any more common factors except 1. So this is the answer. Let's go on to our next example. We have 14/21. Although it might not seem clear at first, both of these numbers are actually divisible by 7. Indeed, we can write 14 as 7 times 2 and 21 as 7 times 3. Canceling out the 7 out here would give us 2/3. Let's try another example. Say if we have say 15/90. Now, as I said a while ago, one method to solve this one is to get their GCF, and that is actually an efficient method, but I prefer trimming it down. So like for this example, the first thing that I can see is that these numbers are actually divisible by 3, since 15 is actually 3 times 5, and 90 is actually 3 times 30. So I can cancel 3 out here, and that would give me 5/30. For this one, we can also see that both of these numbers are actually divisible by 5. So we can write this as 5 times 1 all over 5 times 6. So canceling out the 5 out here would give us 1 over 6. So like in this example, I could actually quickly divide this whole by 15, but that is hard to see at first, that 90 is divisible by 15. So I prefer to trim down the numbers gradually by removing a common factor, like in this case, starting with 3, then with 5 afterwards. But if you prefer it to be a in terms of solution, if you prefer it to be more efficient, you can first get their GCF. So the simplifying of the fraction is much simpler. Let's try out another example. See, we have 36 over 66. So first, we can see that these numbers are divisible by 2 since it ends in it is a even number, both of them. So we have 2 times 18 all over 2 times 33. Cancel that out, would give us 18 over 33. For this example, observe that these two are actually divisible by 3. So we would have 3 times 6 all over 3 times 11. Canceling this out would give us 6 over 11. Let's try a larger number. So say if we have 2,520 all over 3,690, the first thing that we can observe is that they actually both have a common factor of 10 since it both ends in 0. So we can immediately cancel that out. So that is a good tip in simplifying fractions. When you see zeros at the end of both numbers, you can quickly remove that out. So let's just focus on 252 over 369. Now observe that they are actually both divisible by 9. Indeed, if we add their digits, we would obtain both 9 in these numbers. So we can factor out 9. So 252 is actually 9 times 28 all over 369 is actually 9 times 41. So we can cancel that out and we would have 28 over 41. Now is this the final answer? Actually, it is already the final answer. Well, the reason behind that is because 41 is actually prime already, which means that whatever the numerator is, except if the numerator is a common multiple of 41, whatever it is, their common factor will be 1 only. But if you do not know that, you can actually try to factor this out. Get its prime factorization. So we would have 28 is equal to 2 squared times 7. And you can try to divide these. You can try to divide 2 and 7 in 41. And upon trying that, you would actually see that both 2 and 7 are not divisible by 41. So this is indeed its lowest terms. Now let's work on some examples wherein what we have are actually variables. So say if we have a squared all over a cubed, we can actually write this out as a squared times 1 all over a squared times a by loss of exponents. This one is actually a raised to 1. So we can cancel this out, and that will leave us with 1 over a. So even though we are dealing with variables with the same principles, we can actually get its lowest terms. And this idea would actually be useful, especially if we deal with algebra in the future. For our final example, let's try 60x squared y cubed all over 120x y raised to 4. So clearly, now for this one, we know that 60 times 2 is actually 120. So we can quickly cancel that one out. So we would have 60 out here, and at the bottom we will have 60 times 2. Now for the next one, for x, observe that x squared is actually x times x. So we can cancel one of those as well. Now for the y, observe that y raised to 4 is actually equal to y cubed times y. And y cubed is equal, just y cubed. Yeah. So now we can actually cancel out the common. So first is 60 x and x, and y cubed and y cubed, which would ultimately leave us with x all over 2y. Now note that we don't know if actually if x and y has a common factor, but if they do, it would actually look like this. So we factor out x out here, it will look like this one. But this is just a bit more complicated, so we don't look onto that, and rather we take this as the final answer, because this in fact really looks better than the one that we showed. So for this video, we have presented several examples on simplifying fractions from basic level to harder level and to involving some variables. So that is all for this video.